This is Minecraft.
On the Zoom, maybe it's not
Oh my gosh. You know what it
He says Hi everyone. Okay, I worked on Minecraft. So a big thing that's going to need to happen in the near future is as we have more robots in our lives, they will need to continuously learn. I got really inspired by this Andrea Karpathy Animals versus Ghosts blog post, which if you haven't read it yet, it is definitely worth looking at. And he says here, we do not have, in fact, an actual single clean, actually better less than build, turn the crank algorithm that you can unleash upon the world and see it learn automatically from experience alone, like an animal might learn, or like the go-to robot dog might learn. So now, almost. Yes. In Minecraft, I created a continuous learning policy that where the Minecraft agents learn just from themselves. So you can check this out. I based it on Mamba 2. You can see the worldview as well. I'll pull this up. Here's the model architecture. Let's see here. It uses a snake space model instead of transformers, which I thought is interesting and I hadn't built anything with before, so I wanted to experiment with, as well as the JEPA latent space to then do the coordinated rollouts and choose the different multi-step, actions that would lead us to the greatest reward in this environment. So it can climb the skill tree and craft things and work together. And then for real world use, of course, our robots are going to need this themselves. So I trained in Isaac Sim. These are continuously learning robot dogs in this environment that someone will take home from this challenge. That's it. If you want to see the actual working demo, it's here on my Sparks at Home, continuously learning. Based on the suggestion of someone else, now they kill each other. So they will get a reward and the possessions of the other unit, so they have different action space as well. The world should load behind them at some point, but I'm going to take time from other people. So anyway, thanks. We're hiring, so if you work in machine learning and think this stuff is interesting, come talk to me.
Wonderful. Okay, wait, stay on stage, stay on stage. Are there any questions from our judges while our next team sets up?
If you have to spend another week, where would you focus it?
I think you could let this train for several days, for a week, and then it would have more emergent interesting properties and collaborative properties. There's agent success criteria as well. So their reward is not only per individual agent, but achieving the group together societal advance.
Tell us more about the company, Lou.
We got a OT, other transaction authority to work on. We got an other transaction authority to work on big macro global state economic and climate and geopolitical models to do other types of various predictions and rollout for people that care about those sort of things. That might be a government, or it might be insurance, or whoever else works in that. So training world models, if you like doing this, evaluating policies, building robots that want to do those, continuously learn like Minecraft agents. That's what I think we need now. Yeah.
Thank you.
Great.
Hi everybody. So I'm using a lot of agents to work. I have at home, I have a Mac Mini who is full-time only for agent stuff. I connect with it with Codex also today, and then make towing cars. One big thing I have often is the problem that I have certain ways how I save stuff And sometimes I have the same problem if you need connect or something, or you have GPU saved with a SSH code. I want some automatic memory which improves over time. So every time I make a mistake, it will update. And this week there was 2 big papers about gradient descent, or like about optimizing your skill MD automatically. So the analogy is that you don't train weights here. Who gets updated if you make a mistake? The skill MD gets updated to make a mistake. And I thought, why we don't make it bigger? It should run full time on machine, and every 30 minutes should read my whole terminal history and then update what I did or learn from it. So every time I make a mistake or the agent makes a mistake, it learns from it, updates the memory. Every time I use a specific folder, it updates it, learns where the folder is. Every day I use a specific SSH key, I log in somewhere, it remembers it, so I can use it again. And like it's actually working and it's very useful, but it doesn't look so nice to demo. But to show it here, this is my Mac Mini screen here. This at home, running all the time, regardless what I do. And I can now here start. Please be working. The internet connection very bad. Give me 1 second. I will SSH again in. Yes, echo. So the demo is very simple. Just started in terminal, 20 cents, memory help. Can you see? And auto is what I use. When you use auto, it will read your whole chat logs, your whole terminal history every hour and updates its memory based on it. So I don't have to save anything manually anymore. It will learn and improve over time. Thank you so much. This was my very decent memory.
Any questions?
Yes.
Cool demo. What was the most interesting thing that the agent learned?
Currently, it's just like certain ways. So when I do new projects of hackathon, it usually saves on that project hackathons folder, and it learns this automatically. If I SSH to my GPUs, I have this way saved in, but currently the memory is very short. And you kind of want to gatekeep your memory, so the threshold is high to save somebody. You don't want to waste it for a lot of tokens.
Did you benchmark the memory system against other memory systems?
No, yeah, we still have to do that. Yeah, that's true.
Would you recommend local models for this?
Local models is always cool. I currently like brute force it. I have 200 bucks for codex, so I just use it until I'm at limits, and then sometimes I use local models. But obvious, they are cool and good for coding, so like definitely try it out. Thank you so much.
Thank you very much. Up next, we have hardware ops. And one more, if you are demoing tonight, would you all please go to that side of the room so we can get you set up on the Zoom? Thank you.
Can you guys hear me? Cool. Hello, everyone. I'm Johanna, and I build hardware ops. So let's look around the room. The tables, the stage, the chairs, everything around us was manufactured. It went from a design to a design engineer, to a supplier, to a manufacturing floor, and it got made. So what we've tried to build today is an agentic org that manufactures a part and continuously improves. So in very simple example, we used the engine's logo, which is this gear, as our prototype. So we want to make this gear. We want to make 10,000 of this a week. It's going to go into some sort of a robot car, and we need a lot of it at a tight cost, which is less than $1.20. So what we've built is really simple. There's a head of programs that you give to your constraints, and that's the orchestrator. It talks to the engineering org, the strategy org, and the operations org. And those are agents that spawn sub-agents. The engineering org, you have design, which deals with CAD, specs, stress concentrations, etc. And it deals with manufacturing. How much are we producing per hour, per minute, per second? Sourcing is the supply chain guys. Who are we buying from? Why are we buying from them? And for how much? Logistics, they track FedEx, freight, dollar per unit, and safety stock. And then all of that is in a recursive loop that continuously improves and learns. So we use the Core Weave platform to improve and learn on this agentic system. So as you can see here, we have an eval criteria with some ground truths. So we're optimizing for cost, throughput, and compliance because this gear cannot break. And resilience. Is this supply chain good enough for anybody to use it reliably? If a supplier burns down, can we get another part from somewhere else? And of course, lead time. So we had the system go through an MCP and an A2A, which is an agent-to-agent negotiation platform, where design and compliance stock, sourcing and resilience stock, and here we caught that RPN, which is a risk processing number, was more than 100. So that triggered, it did not work, and a human would have to go in and look at it. So in simple terms, we improved our objective to 0.97%. But the most important thing is, what are we comparing it to? Okay, thank you, 41% improvement from a single agent.
Any questions from our judges or the audience? And War Room, you are up now.
What's the next step in terms of making this work? Like if I took you to Whoop right now and said, let's do this with every piece in the Whoop, what's your next step?
Very great question. We'll look at the designs. We'll put it in the system. We'll do a small demo trial with, let's say, a simple part and see how it works. And if it works, which I think we could get it to work in a week or two, at a reliability of more than 85%, we'll do a small pilot with 3 or 4 parts. After that, 10 parts, 100 parts, then we can do the whole loop. Anything else? Thank you, everyone. This was a pleasure.
Thank you very much. All right. Up now we have War Room. Up next is Letter Lens. We're still looking for Saddle, Max Shield AI, Trust Agentic, Package Quarantine, and Tree Service Storm. If you saved your first draft under a different name, please go back and look through and make sure that's not you, because it might be.
Hi guys, so yeah, I'm Baram. I've created War Room. Basically, it's kind of like a startup for startups, you can say. So what it does is basically, whenever you deploy something, you get errors, and you have to like take out like 2 hours, 3 hours to like figure out where the deployment issue was and what was actually the root cause of it. Because like random day, like yeah, 2 days yesterday, my friend got a call at night, and he was like, the man was like, there's something wrong with the website. I need your help right now, and then he had to like get it with the laptop, start working out for like working for 2 hours and find out what was the issue that was causing the error. So what you do is basically I've built using agents, where I've created 3 agents, a log agent, a metric agent, and a deploy agent, where you can paste your logs, like all the files from it, and then the agent, and then over here, let me just start it fresh. For example, I have the payment logs which I have. I'm just gonna like trigger the agent now, and all the agents individually look up the errors and what is happening, and then gives the commander all the results. So you can see over here, for example, over here we could see that deployment has over here in log it says deployment issue, but it also says like a payment service issue. So basically you can see it says a null. The log says there's a null token issue, but the metric agent says it's a deployment issue, and the deploying agent says that this is an issue with the deployment 4471. So you can, and then the commander gets to know like with the timestamp of what the log happened, which error was first, so that it's easier for you to just go to the error and fix the problem than finding like wasting 2-3 hours to like find out what the issue was. And then here you can see the task, what you have to do. Basically, it knows that there was an issue with this one, so you can just fall back to the previous deployment, so that until the the website is until the error is fixed, the previous website or stable version can be done on the website, so that other people can use it. And there will be cases where like both the logs are saying the same issues, so you can like what in that case I've created an extra agent. So in case like call the authenticator. So basically, if something is similar, like the even the first round is not able to conclude like what exactly was the main issue. So again, then the agent will again take all three scenarios, basically run like a round 2 test of all the errors, and then finally give an error. So if you want, I can just show you. I have like a live. Or I've also added a feature where basically you can just put your GitHub link or like a app link, and then it will basically show you like just a second. Like so here you can just put the link, and then it will just scrape to the link and it will tell you what exactly the error was. Like for example, for now I can just put my GitHub link, but since it's deployed and doesn't have any issues, it won't give an error, but it'll just show you like okay. So all the agents runs and just says everything is good, there is no data loss, and there's everything is good. Yeah, that's just small thing which I got built today. Yeah.
Thank you very much. Okay. That was War Room. Up next is Trust. Oh yeah. Up next is Trust Agentic. If they come help set up the laptop, and War Room. Don't leave yet. War Room. I'm sorry, I don't know your name, but War Room. If there are any questions from the judges here.
I saw some weird emails.
Yeah.
Did you do some evaluations?
I did do. So I couldn't get the time to show you, but like yeah, I'll just bring it here if it's okay. Okay, we'll share it. Yeah. So yeah, I have done like a REST evaluation. So I ran all the test cases. It says that all the 17 cases over here. Oh, just let me put it here. So basically I'm tracing all the logs, so you can go to each trace and see like basically this agent used OpenAI to like do the chat. You can change the models. I'm using OpenAI over here. You can change everything. So all the things are being traced over here. Which agent is using which model to do what evaluation. Just in case if you have to find out more, you can just come to the trace and you can find out. And then I've done like an evaluation set of all the test cases which I had done before, like 2-3 hours back, and it gave me a score like all the test cases passed and everything. And you can go to results and you can like see individually for like, each of them. Like yeah, I just wanted to like play around with waves and just see what can be done better. So I just played around with it. Yeah. Thank you guys.
Hey guys, we're Team Trust Agentic. My name is Cole.
I'm David.
I'm Prathamesh. I'm Abhijit.
I'm CJ.
So last week, AWS packaged Amazon's shopping AI stack for any retailer to deploy a front-end agent so that people can buy through the agentic interface. And what we have done today from zero is that we really want to know what would the future be like when all these Amazon resellers, all these Shopify sellers have their agentic interface. And what if they're lying? And when we're asking our agents to make the purchase decisions, and these stores just have spamming or prompt injections or all these kind of things that trick your agent to make the purchase while that solution or product is not the target solution for you. So what we've been building here is the Trust Agentic interface where we are helping the buyers to really understand and detect what are the potential prompt injection tactics that these agents might do. So as an example, for Mara Okafor, which is our persona who is asking the questions of finding a wireless noise canceling headphones, she will pass in all the personal context, the need for the product, and also the planner agents would be doing the search across the sellers to verify, okay, what are the stores, what are the product description they're providing, and we will be checking
the prompt injection, commerce fraud, storefront lures. So these are some of the example we have detected in the way that it creates certain alert so that eventually it passes down to the concierge agent, giving the buyer a final conclusion of these are some of the stores that are spamming, these are the stores that is credible, and we've been integrating with weights and biases to really see how the agents get tricked along the way and how we can really map out the user journey of these agents. So for example, this is a snapshot of a potential prompt injection signal, and it says the detail is possible prompt injection markers in listing or reviews. So that's us, Trust Agentic, and we're hoping to build a safer agentic commerce in the future. Thank you.
Thank you, Trust Agentic. Stay on the stage for questions while Package Quarantine, you're up next. Okay, judges, do we have any questions?
Great concept and great demo, thank you. Where's the flywheel? As your system works, how does it learn from its own activities, especially failures?
Okay, that's a very good question. So I think this is our very first step. Then we need to collect enough data because right now we just use some synthetic data and some data we got on the website. But what we want to do next is we want to get involved with more user, and then user search more merchant or online shop, and then we will get more data. And based on this data, we can help with maybe like large language model post-training process, or help build AI agent, use a CoreWeave to evaluate the behavior of the agent, and then keep the flying wheel start to run and drive our business. Thank you.
Any more questions? All right, next group.
All right, hackers in the house, this is for you. We are team package quarantine. I know quarantine has some trauma, but this is a little bit different. So I always ended up with having 4 or 5 Cloud Code sessions running up in the parallel and just accepting everything, just crying, make it to work. So always directly access terminal and install any random thing. By any random thing means literally any random thing. You can see in the news where recently Light LLM package got installed. It installed some backdoors. Basically, it pulled out all config files, API keys, and it just transferred to the hacker. And this can bill out like thousands of dollars to us. So to avoid this, we built a package which basically has a agentic harness around our vibe coding session, which basically tracks all packages that we are going to install. And before even installing, we run it into Docker, we analyze them, we analyze recent news about these packages, and we just flag them if it is good to go or not. So let's go to the demo.
Yeah, so basically the goal is to quarantine and contain the virus before it spreads. So whenever you try to do npm install or pip install or any of the install, without even getting the code from the repository, what we do is we try to mimic and install that in a separate Docker container, and we see that whether it is accessing your credentials or not. And for example, if there is a hacker lying somewhere else, then from my local, I need to make a network call to that hacker. And that network call is the thing we can trace on it and see whether it is going out or not. So that's what we have built. So I'm in my Docker container, and so yeah, this is for example, this is the fake env file. This is my Claude session, and we have built a fake package called evil demo, and that is a post install script. And what I'll ask an LLM or a Claude Code to do is, let's install evil demo and see what happens. So these are the credentials. I'll just zoom out. And yeah, so this is what we do, right? As a developer, we do a yes, 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 and it goes on. Now, this should actually, so what this is doing is it is trying to access the credentials inside my Docker container. So this should not be the goal of any package, right? It should do its job. It should not access my private details. So yeah, what we see as a result is that, okay, this package is blocked. Now we need to analyze it. So this is the CoreWeave dashboard. Now let's see. So this is the sandbox agent that it ran. Yeah, I'll just open up, and yeah, can you guys see the file accesses that it did? It tried to access my AWS credentials. So I mean, even before, so this is what we act as a prior version, and yeah.
Sorry, guys. Okay. Up next is Letterlens, and while Letterlens is setting up, do the judges have any questions for package quarantine?
Great question. What's the latency overhead in typical installs, would you say?
Yeah, so there are not many files that gets populated. It's just trying to access those files. So it's just read time or very less latency. You can get quickly results that whether your package tried to access and read your files or not. Thank you.
Hi, I'm Wafa.
I'm Colin Gramsria.
I'm Abhishek.
Nick.
And this is Letterlands. 77 million Americans face civil legal problems every year without a lawyer. And it can cost over $350 to get an attorney. If you don't get an attorney in time, it can turn into a costly mistake.
So oftentimes, when it comes to legal notices, people will receive these very intimidating pieces of paper, and they may not have the legal knowledge needed to understand exactly what it means. And just to hire a lawyer and consult, it often costs hundreds of dollars. So Letterlens can almost be seen as sort of like a pre-screening tool to give people an idea of exactly what sort of legal situation they might be dealing with and how to find resources to help them out with that.
And so this is a debt collection letter that you get from your attorney of law. So we'll analyze it. And Abhishek comes up. And so you know how it basically works is we have an orchestrator agent to what? Yeah. So we have an orchestrator agent to kind of divide up the tasks between our two specialized agents, or three specialized agents. One specifically for rights, one for obligations, and the other one's for trust, I think. And so it divides the work among those agents to pick apart the document, and it does them in parallel. And then it would go to the synthesis agent that Abhishek can talk about.
So the risk, rights, and obligations agents, they run in parallel. So they don't get data passed from one to the other. And then that all gets compiled, sort of, what they've come up with by the synthesis agent. So it gives you sort of a clear overview of your position. And then it gives you a sense of how urgent your situation is. And there are three different sorts of tabs. So this tells you that this issue is worth a second opinion. And it gives you due dates among other information. And then here we have a create email that allows you to draft an email to get help from an attorney. And this feature for the geographic location, it extracts your location from the letter itself, and it searches the internet in live time and finds legal help.
So the way we use CoreWeave is the weights and biases. It actually helped us track all the agents. We can see the latency, and it was able to help us design the UI so that we know we can just show the user whether it's urgent or not until they initiate the legal drafter so that they can draft a response to the legal notice. So we did 4 test runs, and you can clearly see how we use CoreWeave's code to guide our development.
Thank you.
Thank you guys very much. All right. While denial defense is getting set up here, with Letterlands. Is there any questions for Letterlands from our judges?
Yeah, quick question. I like the lead gen for the lawyers piece, like allowing to farm that out to anybody who might want to help you. Have you thought about, my friend the other day got sued and she called me up and she said, what do you think about this thing? And I was like, go talk to ChatGPT, figure it out, right? But I think there's a whole component to wanting to hear what other people have gone through, different scenarios like that have gone through. Have you thought through what the next step on the social component might be beyond just the kind of lead gen for lawyers? Like giving visibility to other people going through the same type of shit.
Yeah, a lot of the data is confidential, but I guess you can use number one the geographical location, and we used Appleby MCP for the lawyers. So definitely optimizing the way we search for our lawyers instead of just being geographical. Maybe like some more context from the document could definitely help like really narrow down like, who can actually help you with your problem.
Okay, cool. So I feel like one thing that I've heard a lot is just like interpretations of the law differ from person to person and, you know, likely agent to agent. I guess how would you deal and what would your strategy be for those kind of disagreements?
I think that's a training issue. The models get better as it's trained on more and more similar kind of situations. So that's how we'll deal with it. Like if it's able to be trained in a lot of different similar kinds of scenarios, and it can give a prediction on, you know, what is the best solution to such your particular case.
And to add to that as well, one other possible solution we could look into is we have like some aspect of this already called like the risks agent. So that sort of analyzes the worst case scenario. And so we could have other agents analyzing other perspectives. So you could see those for yourself, and those would come together with a synthesizer for a basic overview. But you still have access to those different perspectives from the different agents.
And you know, just like one more thing on top of that, like on top of all that, and maybe working with like directly with lawyers, and then trying to help them with the evaluation process, trying to do like one-to-one, like we give the model specific documents, we input them, and you know, depending on what lawyers specifically think, we can use that to train our models better, especially with ways of life.
Thank you.
Thank you.
Hi, I'm Abhishek.
Hi, I'm Saitani. Today we came up with the architecture of denial defense. So first I'm going to say about on what problem we build this. So health insurance denies 1 in 5 claims in the United States. So less than 1% of patients actually appeal for it. So the reason isn't laziness. Drafting an appeal that survives the insurance medical reviewer means arguing with an opponent who isn't in the room. So we build the opponent. 3 patient side agents work in parallel. They pull clinical evidence, policy citations, and California IMR precedent. A 4th agent, insurer defense, has no tools, just pure adversarial reasoning. It stimulates exactly what the insurer's medical reviewer would say back. So the patient agents see the critic, they revise, 2 rounds total. The architecture pattern is supervisor worker with adversarial critic and round-based revision. So now it's a live demo. So here is a real Oscar health denial. Patient with mast cell activation syndrome. So now let's run both systems. The single agent baseline on the left, our hardness on the right. 3 things happen on the hardness side. The patient agents run in parallel. The insurer defense agent attack the weakest claim. The patient agents see the attack and revise. Then the critic attacks again, 2 rounds. So left, it's a generic baseline template, and on the right, our hardness notices the specificity, cites AAI guidelines.
So we evaluated 15 real California IMR denial cases on 4 quality dimensions. The harness wins on the metrics. The architecture is designated to improve. Citation specificity, 10% more named clinical citations, 3.87 versus 3.53. Federal protection invocations, 37% more invocations of and No Surprises Act. The baseline systematically misses these. So this architecture is built on LangGraph for orchestration, OpenAI for reasoning, WNB Wave for the full evaluation harness. So it's 3 agents, 2 rounds, 1 decision that stands up to attack.
Thank you guys very much. All right, up next is Saddle. While Saddle is getting set up, are there any questions here?
Then, do you guys have plans to have an agent contact the insurer on the patient's behalf, or would it just kind of give you the argument to make on your own?
Sorry, could you please repeat again?
Yeah, I guess would there be a final step where another agent could contact the insurer on your behalf?
No, it's the patient. It's the patient who is going to upload their claim. So depending on that, as we build the 3, multi-agents, they're going to debate among themselves and they're going to create the draft for the appeal.
Just a quick note of the demo and the concept. Take a look at the history of Athena Health. They focused on claims processing, and maybe that's your future.
Yeah, right now we are actually EDI developers, so we're working on it.
Thank you so much.
Okay, great. And then I'll also just say that Project Sophia is on deck. This is Saddle.
So, hi guys, I'm Nitin and this is my friend Rudy, and we are Team Saddle. So we have built a self-improving multi-agent orchestration. So basically it's a harness that diagnoses coordination failures in a multi-agent teams and rewires it. So like why does the multi-agent systems fails because of like non-obvious ways, like there may be drops, like retrieval drops, reasoning, or like they are not communicating with each other properly, like, or maybe like one agent is like retrieving a document multiple times. So what we have built a system that analyzes these problems and rewires it to so that the multiple agents talk to each other properly.
So this is our self-improving loop. It starts off with 26 questions, which is our QA bank. The idea is to do root cause analysis on issues that are going wrong given documents. So it starts off with the runner. The runner creates a structured rollout per question. This rollout is then fed into Weave. So we have Weave scores that aggregate the failure profiles, and then Rule Optimizer, depending on the failure profile, changes one exact lever that changes the generation. So we're basically moving through different generations for each task, extraction task that we're trying to do, and it's changing one knob on each of these generations. And it keeps doing this until the correctness scores go up. As long as the correctness scores are going up, it will continue to change generation. As soon as it hits like the monotonic progress stops, it's going to stop moving forward. So these are the 3 escalating topologies that we have. So first, it starts off with a single agent. So it's basically just retrieving and answering the question. Then we have the supervisor and the workers. So basically what that does is it's trying to decompose your query into different subqueries and then sends it off to the workers, who then answer the different queries and then aggregate it back. And the third one, which is the most quote-unquote complex one, is the disable verify, where we have two different agents, both trying to propose an answer to a solution, and then the verifier cross-checks the answer, and then you have retrieval based on the verifier's output. Weave is used throughout as the spine. We are using it for full tracking of all our calls, tokens, the different scores that we provide for each generation.
Thank you, Saddle. While Project Sophia comes and gets their laptop set up, do we have any questions? And when you just see it.
Cool project. So how did you think about optimizing the sound optimization in terms of what hypothesis generation, aggregation, or how the failure modes are being found and so on?
So the way it's optimizing is so we have 5 different scores. So there's there's basically 5 different scores. So there's one which is a goal doc we call. So we have the goal set. In the goal set, we have the goal documents provided for each question. Depending on our retrieval, we first check if we have first gotten all of the goal docs that we need. That's our goal recall. Then there's a correctness, obviously, that we're checking, and we're using that as well. There's 3 more that is kind of escaping me.
Cool, yeah. Thanks.
Thank you very much. Okay, before this team gets started, I'm going to give one last chance to the 2 teams that did not check in with us over by the Zoom, which are Max Shield AI and Tree Service Storm. If either of those 2 projects are in the room, this is your last chance. Okay, this is Project Sophia, and on deck is FDA Drug Regulatory Co-Pilot.
Good evening, everyone. Thank you. In this room, we all had this moment, whether it be in your hometown or in a new city, where you walked, biked, or ran past a nice building or a nice scenic point or a nice place, and you were like, oh, I don't know anything about that place. I want to know more about it. But you never bother taking out your phone, stopping what you're doing, and you end up clueless. Now, what about having a real-time agentic guide during those times? No need to take out your phone anymore. Just go run, walk, or bike, and whenever you go next to a nice place, don't worry about that. Sophia will tell you everything. Now, Pierre, please tell us more about what Sophia can do.
Thank you for the warm intro, Felix. So here right now what you can see is our Sophia interface. So essentially based on the user preferences, we find all the points of interest that are relevant for you. So here we pre-process them, but they're all available here. Now we can also narrate through geofencing as you get into the surrounding of the buildings.
Coming up on your route now, the Massachusetts Institute of Technology, MIT, the private...
I don't know if you can hear very well, but here the core idea is as you get close to MIT, you can actually hear about it and learn more about the building. The second step, of course, if you're a runner, is to plan your routes around the buildings that are around you, to learn more about them. I'll try again to share the audio. I'm not sure it's going to work, but I also will run you through the features. So you can set the distance of your run. Here it's 5 kilometers, the pace at which you want to go, and also the verbosity. So how much you want to learn about the buildings around you. Maybe you just don't want to be bothered. You can connect your Spotify accounts as any good runner, and then you can generate the routes. So we generate both the directions and the building descriptions.
Turn right onto Betsy destination will be on the left. Turn left onto Fulkerson's Story. Turn left.
So I recomputed the process as we were running. So here the idea is that the blue dot is us walking through the city. And we can just move around. And as we enter the proximity of a monument, we're going to learn more about it.
Coming up on the MIT housing. These are the dormitories shaping student life.
So
There are
here,
11
I said I was a PhD student at MIT. So that's why it's telling me a lot about MIT. If you said you were interested in learning more about biopharma, we'll tell you about Moderna and Pfizer, which is also based in Cambridge. So essentially our goal in like an over-connected world, beside all the app, is to reconnect people to the roots that they have. I think it's very important to understand the buildings and your surrounding, to connect with your community, and essentially reconnect to the world around you. Not just through AI, but also through the buildings and the monuments and the beauty that you have around yourself. Thank you very much.
Okay. While FDA drug regulatory co-pilot comes on stage and starts setting up, do the judges have any questions?
Can you get it to be dynamic, so as you're just running around, it will kind of update? And then could you also, instead of planning your trip beforehand, just have it be live on the fly? And then second, could you add layers to it, like history layer or sports layer or, you know, some other type of layer, so that if I'm running around downtown Boston, I might get like the Red Sox, Celtics, Bruins info of who lives where, rather than like Paul Revere running through the streets, you know?
So on the live monitoring, here we have to pre-process it simply because we don't have the inference support. We think weights and biases for the inference, but you know it's limited so far. But the idea is that it would run live on your phone, and because you pre-process the narration, it can just like adapt as you run around. On the second step about which building or which topic you want to focus on, that's the idea of customer relevance that we have, where you describe your interest. And based on it, it selects the best either sites or monuments and describes the history around it based on your preferences.
I love the demo, thank you as well. One thing that I love the history angle as well, just knowing the history, what happened in that area. But also consider the safety and risk aspect. There are very famous examples of military personnel wearing wearables, announcing to the world where they are, and they shouldn't be, so you may want to address that.
Yeah, I thank you for the feedback. I think in general, if a normal person like to share your location with Uber or with Strava, the idea here is to connect it with Strava, for example. And as you record your run, you can also have more information about your surroundings. Obviously, the idea is not to share your location information and keep it private. Thank you very much.
All right, thank you. This is FDA Drug Regulatory Co-Pilot, and up next will be Tree Service Storm.
Hello, everyone. We are FDA regulatory co-pilot, and if you are developing a new drug, one of the biggest questions is how confident are you that the FDA will agree with your strategy? So I'm a regulatory affairs consultant, and for years I've been seeing companies from startups to global biotechs spending enormous time and money trying to answer that question. So the challenge is that the regulatory knowledge is often locked inside the expert of the FDA reviewers, and it makes it very difficult for new teams to access and apply those logics consistently. And at the same time, in drug development, a confident wrong answer can be extremely costly. So as a team, we want to make sure that a problem is solved in a more advanced way. So we are developing this regulatory co-pilot. Now I'll hand it to my team member, Nilay, to express the idea.
Yeah, so this is the entire dashboard. We take a drug right now, for example, CT014, and essentially it's also going to show you the entire pipeline of it's a 5-stage pipeline where the planner is going to split the question into 2 sections. And the researchers, which are 2 different agents, are going to do their own independent research based on the open FDA data and some clinical trials.government files. And once that is done, over here, you can look at an independent critique, which would be another agent would not look at the results of the researchers, but make its own claim based on its own evidence that it has found. And it would silently vote If it's a contradiction, if it's approves, or if it's not anything, so it will stay silent. And at the end, the disagreement engine would essentially just give out a confidence score, deterministically, not through an LLM, but it is just gonna add up to the scores of if this was available and like decimal points, plus point, if it's a contradiction, negative point, in that way, and it's gonna give you a score. And at the end, it's gonna give you the entire slow brief to you guys. We also have the entire audit so these are the things that it goes, the research evidence, and at the end you can also have this weave so that you can pull it up. I think I have one that's already here, and you can also trace everything along with it. To be fair, we also have this planned. Like this is essentially a small toned down version of it, but this is what we initially planned for the large scale object for to begin from a production standpoint. Thank you.
Thank you very much. While tree service storm is getting set up, are there any questions for FDA drug regulatory copilot? Also, City Weave is on deck.
Cool demo. One question about the independent critic. How did you align that to be critical?
So what do you mean by align?
In terms of align on maybe the job expertise that you have in terms of what are the criteria that you
Yeah, so it's gonna pull out these LLM calls and look out on its own independent evidence that it's gonna find through the internet, and that way it's do nothing that's gonna be similar to what the FDA files or like the clinical trials have given. Think of it as a newsroom thing, and one particular reporter that likes to dig into certain things is just gonna pull up certain articles from here and there and try to make contradictory claims, as many as possible. So you have the positive sides, but then you want something that it calls you out to gives you, and the disagreement engine is the one that doesn't hide that. It is also always gonna give you that, tell you what to disagree about.
Thank you for the question. I think that also comes to a one of the agents' role that we kind of integrate both the FDA decision tree. Me and my colleagues are developing with. You need refine like after this project, but we also want to come up with like different disciplines idea, like for instance a clinical, non-clinical, and CMC perspective on their own ideas, and also they want to exchange. They will be separately assessing it from their own expert perspective, but eventually they will present it to the overarching AI to kind of to cross-check if you have missed something out in another disciplinary. So it's like a cross-check validation as well.
Thank you.
While we're figuring this out, does anyone have any more questions for the judges? Not to put them on the spot, but some of them are up to some pretty cool stuff. No questions. This is a unique opportunity, guys.
Yeah.
I have one.
Oh.
Yeah. What would you recommend to the hackers around here after today? What would be usually the best next steps to go from here? With that now, for these great ideas out there. Any recommend to research the market for competitive or get deeper into the ideas? So what would be the thing to look for? Any suggestions?
Yeah. The question is, and what are the suggestions for future hackers and projects? I think there's going to emerge a couple of themes from the ones that are going to be highlighted as the top 3 or 4. So just learning how they selected the mission that they were at, how they presented it, and what resonated in terms of the kind of questions that we were asking.
Any more questions? Okay, so we're gonna go, another question, go for it, yeah, what's up?
Thank you so much. I just have one question regarding agentic commerce, since this is the topic we're researching. The question is, during the fully agentic era, how does these e-commerce platforms, like Shopify, Amazon, Etsy, how do you balance with ChatGPT, Claude, and these AI platforms making purchases? What is the difference and what is the moat right now? Yes. Yeah, never mind.
Do you have an answer? Next, okay. Yeah, we're ready now, so. Okay, and then the next demo will be the final demo.
Hey guys, I'm Hunter. People have been talking about my shirt all day, but yeah. First, actually, I just wanted to say thank you guys. I graduated high school 2 weeks ago, and from Louisville, Kentucky. Yeah. So yeah, I'm from Louisville, Kentucky. I just came up for the week. Been a great time for Boston Tech. We got enjoyed it. Figured I'd go over my project. Y'all probably haven't heard of something like this or expecting a demo about tree services tonight, but here we are. So basically, something in tree services that I thought's interesting is the amount of data we have, particularly like satellites, weather, and a few other things they can really pull together real time now. So with this, I'm basically using satellite data, some weather data to find where trees have fallen over, and then basically have tree service companies look, identify those places, and then send digital mail to help be like, hey, get a discount on our tree service. We saw you had a tree fall in your backyard, stuff like that. I'll go ahead and just play the demo. That should be pretty helpful. Walk through a little bit. Turn off the radar. Oh, okay. Well, I guess it's not really loaded on the screen there, which is kind of shame. Just seems to be stuck. Rats. Yeah. That works. Rats. Replay. Yeah, so basically I set up like a fake storm coming through Boston. Actually tornado might not be much of the weather, but oh, it's trying to take me off Zoom now. Yeah, I did. Yeah. Sorry about this, guys. Let's go. Anyways, that is the service area for the tree service thing. Anyway, so at the bottom it has the storm alerts that have come through. It also ranks like lead priority. We'll also get real time feed. So for instance, these are all the different addresses which it's all were affected by the storm. If you click on property like right here, it'll pull up satellite data. Hopefully the image loads, and just some more information about the person so you can immediately contact them. And then again, you click 15 leads and you can send them direct mail. So it immediately connects with Lob and is able to send out that way Lob being one of the direct mail service providers. Some of the agent stuff's on the right, so showing like, hey, you can contact this person was recently impacted, give you the information real time, and then hopefully when I press the demo thing, it will draw actually lines because it'll calculate the best route for each different truck to go to the different spots. So for instance, right, if you send out 3 different trucks, what's the most optimal route to hit all of those leads? So I can click here on the dispatch, and then you can go ahead and manually click through on the different trucks. But there's something different, pulling stuff together with agents for tree service. Not a vertical most people work on, but something I find interesting and largely valuable. I guess it's probably enough time.
Okay. Our final presenters are CityWeave, who I think are also getting up. I think they weren't able to do it via Zoom, so they're just going to Airplane. Thank you for bearing with us through the technical difficulties. It is a hackathon after all.
Yeah, quick question. So consumers can post tree debris and anything falling over, and then on the B2B side, local business can sign up for that as a service and pay some sort of subscription.
Yeah, exactly. Well, and what's even interesting, yeah, so, the businesses will also be able to get the data of when the trees fall over via the satellites just automatically. So you might have like 500 trees that fall over. Now the tree service companies that signed up just found 500 hot leads that are going to be in the need of the service, and they can contact them before anybody else. Again, sending mail to them already.
So this is a disaster scenario, right?
Exactly, disaster, but also like has weather. And then maybe it's not even like a disaster. Maybe it just gets old, falls over, wind flies.
One of the big challenges in a disaster is that normal accessibility is going to be disrupted. So how are you thinking this will work?
Well, so a lot of times it's more just like going to be some of the minor things, right? You have a thunderstorm come through, it knocks over a few things. More like the residential side, like a tree falls over your backyard. You want to get a stump roof, whatever it is, we'll be able to see just from that satellite data to be able to get the lead service. But yeah, like you mentioned, if it is a big emergency, I mean, you're not going to be going to someone's house when you have a big tree in the middle of the road blocking people, and that gets addressed pretty quickly, right? You don't need the satellite to tell you, oh, hey, there's a tree in the road. People will figure that out. So I guess basically the answer would be, yeah, like you said, I mean, you're going to be able to figure like this is just more for those scenarios. It's like, hey, that you can tell they need their service.
Okay, you can plug this one, this one.
Thank you very much.
I will be sharing this screen, and then, yeah, I'll take this. All right. Oh, God.
And this is our final demo. What happens after this is the judges will reconvene.